Mr. Ravi Kaushik, who is the CEO of AIRTH and a graduate of IIT Bombay. He has executed R&D with IIT Kanpur, IISc Bangalore, and IIT Bombay to develop germ-destroying filters using the immune power of plants to replace germ-growing filters being used nowadays. Mr. Ravi is an air quality expert, owns 3 patents, and has support from the Department of Science and Technology. He was the recipient of Asia Pacific Innovation Academy, stood first runner-up for the COVID solution technologies, and his innovation has been deployed at the RBI, DST, Stockholding Corporation of India, and Schindler Elevators. His research promotes Think in India and Make in India campaigns. Today, Mr. Ravi will talk about germ destroying filters, a technology from IIT Kanpur and IISc Bangalore. So, delegates, let's welcome Mr. Ravi.
This session is all about asking questions. So what I'm going to do is following up on the germ destroying filters that are replacing germ growing or conventional germ growing filters, which has been developed in the labs of IIT Bombay, IIT Kanpur and IISc Bangalore, and has been supported by Department of Science and Technology. First of all, it's really important that we should understand the importance of narrative. Most of us, everybody here is really interested in indoor air quality, and as shown before in the last presentation also, we know the problem is air pollution and disease transmission, and this is how we portray it, like because of allergen, particulate matter, primary PM levels, and then secondary pollutants, these are these, and health effects are these. However, I think it should be more personal. And by changing just the narrative of the problem, what if I asked you, or if I asked the client, do you want to increase your life up to 9 years? You have to do just one thing, and that is to breathe clean air. And we have established research now from various different agencies which support the fact that Indians are losing 5 to 10 years of their lives just because they are breathing bad air or polluted air. So that's also not just the health benefits, it's about better productivity and then the energy savings. Everybody is interested in energy savings because ultimately it leads to lesser operational cost. So that's, I think, what should be conveyed in terms of when we are talking about indoor air quality, and not just the names of the pollutants and then the health benefit, because this is what is personal to everybody. Like from pollutants to actually benefits, it's not a CSR activity, and this helps you save money and your health. And also the customers that are getting into your premises, they will feel more confident because now they are getting into a clean air zone. Also, if you have employees, their productivity will increase. So that's how I think the narrative should be. Now coming to the problem now, and also changing from air pollution and disease transmission, these are the problems and not the pollutants. Everybody is losing some part of their lives because of the bad air that they are breathing. It is affecting our productivity, and bad air means it is expensive. Also, lesser life of your cooling coil and your condensers. So that's the problem. The current methods that are being used in industry, one is air filter, which is like conventional. However, the problem with them remains, and it's a well-established fact that they themselves become a breeding ground for germs because they just work on a capture mechanism where germs are getting in there. They grow there because they just need carbon and nitrogen for their growth. They get that from dust and nitrogen available in the ambient air, and they grow there and can again resuspend back because of huge pressure drop that we have across the HVAC system. Then ionizer or ESP usually leads to generation of ozone, which again is something, and also dependent, it's the electromigration and dependent on kind of ventilation rate that you have. So kind of really tricky, and most of the times the effectiveness is quite low. Then fumigation, again really harmful for people and leads to UC generation, and now every industry is trying to identify what's the alternative for fumigation. Then UVGI, if it is being used in the vicinity of human beings, again very challenging. And if it is being used in HVAC system, what we have observed so far being in from the research side, that it is not very well designed, and when you see the residence time, the deactivation capacity of such UV lights being used in HVAC system would be less than even 10%. Then we have plants. However, plants, yes, we want to understand the fact how plants can help with the air purification. But what studies show, they can only help with VOC reduction, but not in particulate matter reduction. So we should understand the limitations of every technology. And this is a tablet format of exactly how this every technology and the drawbacks that it has. So at IIT Bombay, IIT Kanpur, and IIC Bangalore, we have identified this gap. The filter should not become a breeding ground for germs, and what we have then done is made a germ destroying filter which has been coated using plant-based biopolymers. And it recently we have done testing on live SARS-CoV-2. So what we have done, live SARS-CoV-2 was sprayed on these coated filters, and as you can see the test summary, in 24 hours of contact time, we were able to achieve 99.24% reduction, which was tested on Delta variant of SARS-CoV-2, which was responsible for a second wave of COVID that happened in India, and because of which we have been on news. So the technology remains, we are using plant-based enzymes, plant-based biopolymers, and polyketinic polymers. Polyketinic polymers essentially means they have extra charge on them, and this charge leads to deactivation by formation of ROS, that is reactive oxygen species, and free radicals. The same has been validated various different labs, but at a microscopic level, this is how it looks like. You can see the coated filter, and on further magnification, you can actually see the enzymes being impregnated on the fibers of the filters. This is the one-on-one visual comparison. Both the media are the same. They are HEPA filter media, and what we have done is one is coated and second one is uncoated. We sprayed microorganisms over it and then incubated both. So what you can see here is coated filter is able to deactivate the germs, and uncoated allows growth of germs. And these are the validations we have done, again understanding from the industry. First, it should not increase the pressure drop. So what we have understood, our coating increases less than 5% increment in the pressure drop, which is statistically insignificant. So it works out for most of most of the HVAC ducts. Then second, the filtration efficiency should not be affected because now we have this coating. So it remains the same. Again, we have seen many instances where we have increased the filtration efficiency. Then third, other filters, they allow growth and we should be able to deactivate it. And we have tested on not only just virus, we have tested on bacteria, that is gram positive, gram negative, and even on fungus, which are really resilient to be deactivated as compared to any kind of virus, be it SARS-CoV-2 or Ebola. Then fourth, which is really important, is safety, and it should be non-toxic. So what we are doing, I'm sure many of us might have heard about antimicrobial coatings. Most of them use either copper or silver, which is a toxic heavy metal, which again will lead to ultimately go into the atmosphere and affect humans. So they are not environment friendly and they are really toxic for humans. So what we are doing is biodegradable coating. So it is one, completely environmental friendly, and then second, it is human friendly as well. And the coated filter should not leach out anything. So again, that is something that we have tested for. So all these validations, all these questions that we got from the industry has been tested for, and that is how we are moving forward, because again, it was developed in India from the labs, has to be taken to the market, and because there are so many supporters that we have in the HVAC industry, they asked us the right question and we were able to validate the same. So applications can be in HVAC filters, in car filters, in air conditioners, in air purifiers. So currently we do have air purifiers with us, and we are working with a lot of HVAC manufacturers consultants as well. These are some of our customers. RBI, adopted by RBI, like entire economy of India depends on RBI, and they are dependent on us for their air safety. Kind of a big deal for a startup like ours. Then Stockholding Corporation of India, we are protecting 3 of their branches, which gives stamp paper to entire India. ONGC, Stockholding Corporation of India, should be Schindler elevators to make elevators ride safer. So these are some customers. Not only lab validations, we have a lot of real life validations. Just want to highlight, and I'm sure might be of interest for a lot of people. One is like Stockholding Corporation of India, where we ensure business continuity, because government organizations cannot stop, be it Ebola virus, monkeypox, or any other thing. They have to work. So we ensured business continuity, because of which we got letter of recommendation from them. Second, it's unique, where we were protecting cancer patients, like people with zero immunity, who cannot fight against germs in the air. We were doing the fighting for them. This Vedanta Group hospital, or cancer hospital, did a lot of trials with all the available technologies out there. Ours outperformed in terms of microbial deactivation, lowering down the burden from the air as well as particulate matter in the air. After which they finally installed our system on the patients after 6 to 7 successful discharge with no cross contamination or secondary infection. We got letter of recall from this Vedanta group hospital. Then this in 4 days, so we have tested pomegranates basically, and they were facing a lot of challenge in terms of fungal growth when they were shipping it to abroad. Now what we did was their entire factory has now been protected by us, and they are able to export good quality fruits. In F&B industry, we not only have in cut fruit real life validations in cut fruit industry, but also in sweets making packaging area, in dairy industry, in bakery industry as well. So we were able to, in real life conditions when people are working, we were able to achieve approximately 80% microbial load reduction from the air in ambient conditions, which is like in real life condition, it's really good. This is a diagnostic lab. This problem statement came from a doctor where in this diagnostic lab, there were cases of false positive and false negative because our samples of RT-PCR goes to a black room where all the samples are being tested for whether it is positive or negative. Now, because of microbial growth in the air, these samples were going bad. Now, what we did was we installed our system there and were able to create near sterile condition, and the cases of false positive and false negative reduced. And we've got again a complete study from them. The same study has been done after 5 months. It shouldn't be like in the first 1 month we are able to create that sterile zone, but after 3, 4, 5 months it degrades, like other air filters become a breeding ground for germs. So again, the same thing has been validated after 5 months, and we were still able to create that near sterile zone, and the CFU count was just 1 in the ambient conditions. So this is our value proposition, that we are replacing germ growing filters with our germ destroying filters, and that uses biopolymers from plants to deactivate germs. Just like how plants have their immunity, the same enzymes are being used to deactivate the germs on the filters as well. We were endorsed by even the director of IIT Kanpur. Being an R&D driven company, it was kind of a big deal for us when the director of IIT Kanpur endorsed us on Twitter. We've been on news again because of the impact that we were able to create. And this is again, just imagine yourself entering into a restaurant in a mall, or even your house, where you can have the confidence, you can be relaxed that you are breathing the cleanest air possible. AQI outside can be, for example, 700, but AQI inside can, within the WHO limits, for example, 50. So that's what we are offering. This is our dashboard, because this talk is more about IoT thing. So we do have a dashboard now and doing real-time monitoring. So this is the dashboard, but not only monitoring, ultimately it should lead to something that is predictive analysis using the captured data. So this is what we are doing for some of our customers, where, for example, after how many days they should be replacing their filters. Then with some of, we are working on this remote diagnostics. IoT plays a very important role in remote diagnostic. What do I mean by this is, for example, you have an HVAC system and there is something which has gone bad. You cannot, like, starting from ground zero and then trying to diagnose things. What we can do is using remote diagnostic, like how the current is going, etc., etc. You can actually pinpoint what's the issue, and then your maintenance people can work on that particular issue which has been already diagnosed by using the current as a factor. So you can solve that problem in no time, right? So that's really important as an application to IoT industry, and this is something which will pick up. But in India, I think it will take some time, but that's the hope that it should pick up. So thank you for your attention, and we are trying to become air doctors. Any problem in terms of air, we are trying to solve that. So thanks a lot, and any questions I would be happy to answer.